Yeah, restart that video.
Ah, why? How do you know I was recording?
Okay,
I can restart anytime anyway, so anyway.
okay.
Hello guys, so today we're doing LeetCode question 226, invert a binary tree. This is an easy question. Given the root of a binary tree, invert a tree and return its root. So example 1, the tree is 4 with a root 2 and 7. 2 has a children of 1 and 3, and 7 has children of 6 and 9. So we invert it, so it's like a mirror effect. 4 has now got a left child of 7, right child of 2, as you can see they're inverted. 7 has got, again, left child of 9 and child node of 6, so they're inverted instead of right 9 and 6 left. And 2 again inverted, 3 and 1 rather than 1 and 3. And example 2 is, let's say 1, 2, 3, and then 3, 2, 1. As you can see, it's inverted. So the way we'll do this is with depth first search, and it's very simple. We just pretty much reassign the left node to the right node and just recursively do it. So let me show you how to do it on the whiteboard. Let's say we have this tree here. So we have to create a base case. So if the root is null, we return. If the root does not exist, if the root is empty, we return null pretty much. So, and then from there we go here. Let's say we're at 4. We recursively check root left, and well, first we get a left root, which is root of left. We save it to a variable left, so left is equal to root of left. So then when we reassign root of left to root of right, we still have the root of left variable. So now we create root of left is equal to root of right, so we reassign it to the right variable, and then we assign root of right to the left variable which we have saved, so we still have it. For example, now we're at 4. We set root of left as root of left, which is 2. And then we set root of left as root of right. So now 7, root of right is root of left, sorry, is 7. And root of right is now set to left, which is 2. So we set root of left as 2. Bear in mind, when we change these two will also swap round. So that means that now this will be 1 and 3 here, 1 and 3. And this will be 6 and 8, 6 and 8. The reason being is because, there's no black. The reason being is because we're not just switching the nodes, we're switching the whole subtree completely. Root of left has the children of the subtree, so when we switch the root, the children are also switched. So then we proceed. We then go to recursively execute the depth first search with the left side. So now we're at 7. So we switch root of left to root of right. So our left is 6. Root of right is root of left. So now, root of left is root of right. So 6 is now 8. And then root of right is left. So 8 is 6. So now we're done with these two. Go again to the left side. So we're at 8. But as we create a base case of if no root, we return null. We return null, we go root of right, null, go back up to 7, 6, null, enough to switch, go back up to 4. Now we're at 2. So now root of left is 1. So we save left as 1. And then we set root of left as root of right, so now that's 3. And we set root of right as left, so that's 1. So 3 and 1. Now we go to down 3, nothing here, we go back up, right, nothing here, go back up here, back down, left, nothing, right, nothing. So we return the root 4, which contains this current tree here, which is reversed. So let me try to do this in code. So first we create the base case, so if there is no root, we return null, so it doesn't create an infinite loop. Then we set the left variable as root of left. Bear in mind you can just do this with root of right. So left equals root of left. Then we set root of left as root of right. And now we set root of right as left, and then we check, we invert tree so that we depth of search recursively. So we recursively do this, so we recursively do this for the left root, and we recursively do this for the right root as well. So invert tree root dot right, and then we return the root. So let's run. I see it passes. Let's submit. As you can see, this is the first time complexity. This is a time complexity of O(n), as we're looping through the whole tree, and a space complexity of O1, as we're not storing any extra variables. Thanks for watching.